Welcome to the last part of our chapter, alternating current. Now we are discussing the last topic, that is the AC generator. AC generator is a device which is converting the mechanical energy into electrical energy. So this device is used to generate electricity which is alternating in nature, which is basically working on the principle of conversion of mechanical energy into the electrical energy. What is the working principle? It is working on the principle of electromagnetic induction. That is, whenever magnetic flux linked with the coil changes, an EMF is induced in it. So, electromagnetic induction is the working principle for it. What are the basic parts of the AC generator? An AC generator basically consists of two pole pieces of the permanent magnets which are concave in shape, north and south pole. Then it consists of an armature coil which is shown over here in the diagram by with A, B, C, D. This is the armature coil. The two ends of the coil, they are respectively connected with two rings which are known as the slip rings. For example, in this figure, end A is connected to the slip ring R1, while end B is connected to the slip ring R2. B1 and B2, these are the carbon brushes. B1 is permanently attached with R1 and B2 is permanently attached with R2 slip ring. This is the shaft or the axle which is passing through the armature coil connected with it. So when this armature rotates, due to the rotation of the shaft or the axle attached with it, the magnetic flux passing through the coil changes, and which is going to induce some EMF in it. And if the coil happens to be in a closed circuit, due to that an current will also be induced in it. Now let us see how does this work. Suppose the axle or the shaft attached to the coil rotates the coil in the clockwise direction, due to which the end AB of the coil, this end AB of the coil will be moving in the upward direction, while CD and it will be moving in the downward direction. The direction of the magnetic field line is from north to the south pole, as shown in the figure. Here in this case, the arm AB of the coil is moving in the upward direction, while the magnetic field of the magnets is perpendicular to direction of the motion of the armature arm AB. So if we apply the Fleming's rule, then with the help of Fleming's rule, which we can determine the direction of the current induced in it. So if we apply Fleming's right hand rule, the motion of the coil is in the upward direction, magnetic field is towards the left side. So in this case, if we point our thumb in the upward direction, index finger in the direction of the magnetic field, then the middle finger indicating the direction of induced current is pointing perpendicular to the plane of paper away from us, that is from A to B. So the induced current in the arm AB is flowing from A to B. Similarly, for arm CD, magnetic field is in the same direction, only its direction of motion is now in the downward direction. So again, if we apply the Fleming's right hand rule, here the arm CD, it will be carrying the current from C to D, that is towards us. Overall, in this rotation of the coil, when arm AB is present on left side, arm CD is present on the right side, current is flowing in the direction A to B to C to D. So ABCD is the direction of flow of current. Now as the coil will rotate, after the half rotation, the two arms AB and CD, they are going to interchange their position. After the rotation, half rotation is complete, AB arm appears onto the right side, CD arm appear onto the left side. Now in this case, CD arm was where it was going earlier downward in direction, now the CD arm is going in the upward direction. AB arm earlier was going in the upward direction, now AB arm will be moving in the downward direction. So again, if we apply Fleming's right hand rule on both the coils, on both the arms of the coil, then through the arm CD, now the current will reverse its direction. Now it will be flowing from D to C, and while from arm BA it will be flowing from B to A. That is the direction of flow of the current now in the coil after the half rotation, it will be DCBA. So in this way, in every half rotation, due to the shifting of the arms of the coil from one side to the another, the direction of the current in the external circuit will be reversed. So this generator, which produces a current which is continuously reversing its polarity after every half rotation of the coil, we call this type of current as the alternating current, or the EMF induced in the coil, it will be alternating induced EMF. So in this case, in one half rotation of the coil, current is produced moving in direction ABCD, and in the next half rotation of the coil, current reverses direction and it flows in DCBA direction. So in one complete rotation of the coil, one complete AC cycle is produced. That means if coil rotates one time in 1 second, it is going to produce one cycle of AC. So its frequency will be 1 cycle per second, or 1 hertz. That means if we want to produce a AC cycle which is of a frequency 50 hertz, which is normally used in India, then for this the coil has to rotate 50 times in 1 second in the magnetic field of the concave pole pieces of the bar magnets, so that it can able to produce a frequency of 50 hertz. Now let us find expression for the magnitude of the EMF induced in the coil. Let the coil which we are using is having n number of turns. Area of the coil is A. External magnetic field generated by the magnet is B. And angle which normal to the coil makes with the magnetic field B is theta, and omega is the angular velocity of the coil. So if this is the coil, this is the normal to the coil, and if this is the direction of the magnetic field, this is the normal to the coil. Both are inclined at angle theta with respect to each other. We have already discussed this thing in the one of the earlier video. At any time t, the flux that will be linked with the coil, it will be given by phi equal to NBA into cos of theta, or we can write it as NBA into cos of omega t, because theta is equal to omega t. So by the law of electromagnetic induction, the EMF induced, it will be equal to minus d phi by dt, which will be equal to minus time derivative of the NBA cos omega t, which will be minus NBA into minus sine omega t into omega. Negative sign cancel, we are having NBA omega into sine of omega t. Now this term NBA omega, number of turns are fixed, area of the coil is also fixed, magnetic field strength is also fixed, and angular velocity of the coil in the pole pieces of the magnet is also fixed. So all these four factors are constant. So we can write this equation as E is equal to E naught sine omega t, where E naught is equal to NBA omega, which is nothing but the peak value of the EMF that can be induced in the coil. So this is the EMF induced in the coil. If the coil has a resistance R, then the current induced in the coil will be E over R, which will be equal to E naught over R into sine of omega t, or it will be I naught into sine of omega t. So this is the equation for the instantaneous alternating current. Last, what are the advantages of AC over the DC? First advantage is the generation. Generation of alternating current is much more economical than the direct current. Alternating voltage can easily be step up or step down. Transmission of alternating current is also very easy and economical. DC voltage cannot be transmitted using the transformer because they work on the principle of electromagnetic induction, that is changing magnetic field. DC current is a constant current which doesn't produces any changing magnetic field, so electromagnetic induction is not possible with the DC. So after every few kilometers we have to install DC generators in order to generate the electricity, which is not economical. AC to DC conversion is also easy with the help of the transformer as well as PN junction diodes, but DC to AC conversion is not that much easy, and also it is very costly. So because of this, the advantage is AC is preferred for over the DC. But there are some disadvantages of the AC also. First, its peak value is very high, so it is very dangerous. We know that the peak value of alternating EMF E naught is given by root 2 times its RMS value. Okay, so the AC voltage which we are using in our homes, it has RMS value 220 volt. This means that if we find their peak value, it will be around 311 volts. So that is very large value. So it is very dangerous to work with the AC. But AC cannot be used for electroplating, electrotyping, electrorefining. We cannot make electromagnets from the AC because all of these things, they require constant current flowing in one direction. Not possible with AC. AC is transmitted from the skin of the conductor rather than inside it. Whenever AC currents are flowing from the wires or the conductors, they always flow from the outer skin of the conductor, outer surface of the conductor. We call this effect as the skin effect. So greater the surface area of the wire or the conductor, more easily the current can flow. So in order to increase the surface area of the conductor so that it can easily carry the alternating current, instead of using a single wire, many thin fine wires are braided together, insulated, and they are used for the transmission of AC, whether they are to be used for long distance transmission of AC or whether they are used for transmission of AC within the building. So in order to have greater skin effect, greater surface area, instead of using a single thin wire, we use multiple thin wires braided together so that the surface area can be increased and the transmission can also be done in a better way. Thank you.